Hi, today we are going to discuss about lumped element inductors. Okay, so listen, we are going to directly go to the classes. It will be a small part. Here, I am going to discuss about the features of inductor that's we used in our microwave integrated circuits. So listen, the inductor, we all know the inductor take a form of single or multiple bond wires or wire bond chips inductors or lumped inductors made using the hybrid and MIC fabrication technologies. Okay, so some parameters that will be used to specify or specific for the specification of a particular type inductor. We are used to consider some parameter. So such parameters we are going to discuss here is first one, effective inductance. So in the case of effective inductance, the inductor has associated some parasitic capacitance due to the interturn and ground plane effects, etc. So this in parallel with its inductance, so this inductor that will be a parallel with a capacitor. That means one parasitic capacitor here. So when we are going to consider about the impedance of our inductor, okay, so the inductor value, the impedance of the inductor value, that will be our ZL, so will become j omega L into 1 divided by j omega Cp, all divided by j omega L plus 1 divided by j omega Cp. From here, we can rearrange the equation as j omega L divided by 1 minus omega L Cp. From from these steps, we are concluded that JL is equal to j omega LC. Here the is LC is the effective inductance. So here the LC is the effective inductance of our lumped element inductor. And here we can get the expression of about LC will be L divided by 1 minus omega L into LCP. Okay, from here we can resolve this equation as L divided by 1 minus omega divided by omega p the whole square. From we are going to consider about this impedance of our inductor. This will be parallel with a parasitic capacitor. Here we are neglecting the series effect. Okay, series resistance effect of our inductor. So when we for in the case the below it's the impedance value should be below the first reference value. Its value is generally greater than the nominal specified values. Okay, so for in the case of lumped element, we have discussed the impedance. Okay, when a parasitic capacitor has become as parallel with our inductor. Okay, next we are going to discuss moreover some more here parameter is here, the quality factor. We all know what is the quality factor about the case of inductor. Okay, so the quality factor Q will be equal to omega L divided by R. Here this R is represent that series resistance of our inductor. Okay, some important parameters should be considered. I already said that some more important parameters should be considered when we are going to design a particular application inductor. So, such as the first one is self-resonance frequency. So, self-resonance frequency means it is determined by the inductance value and the parasitic capacitance value. Okay, so we all already discussed here. We get an impedance value. Okay, so from this impedance value it will be conclude here we are concluded that for in the case of resonance value, for in the case of resonance the impedance value should be greater than a nominal specified value. So that's the case is here the self resonance frequency. It is so whenever that impedance is determined with our resonance value, the resonance frequency, okay, so also depend upon that. That means that it will be depend upon our inductance value and the parasitic capacitor that should be parallel with our inductor. Okay, the second point is maximum current rating. Okay, the maximum current rating means the DC current the DC current inductor can withstand. Okay, the maximum DC current. Okay, the maximum current rating means the maximum current for the case of a particular inductor, so will be proper. It can able to properly work. Okay, so that rate is called maximum current rating. Okay, next is a maximum power rating. So that in the case of maximum power rating, the maximum radio frequency power that can be applied safely to the inductor. So we all know for its specification, based on the specification of inductor, the value to give the value of power of our microwave frequency to give our inductor will be varying. Okay, so for in the case for a particular inductor whose highest or maximum power rating, okay, that will be applied to our inductor, that will be called maximum power rating. So ഇത് ബേസിക്കലി ഇൻഫ്ലുവൻസ് ചെയ്യുക നമ്മൾ കൊടുക്കുന്ന മൈക്രോവേവ് ഫ്രീക്വൻസി മൈക്രോവേവ് സിഗ്നലിൻ്റെ മാക്സിമം പവറിൽ എത്ര കൊടുക്കാൻ പറ്റും. സോ ദാറ്റ് മാക്സിമം പവർ വിൽ ബി ഇൻഡിക്കേറ്റഡ് ദാറ്റ് അവർ point, that is maximum power rating. Then next point is, fourth point is temperature coefficient of inductor. The temperature coefficient means the temperature dependence of our inductor. Then the fifth point, that will be saturated radio frequency power limit. Okay, saturated radio frequency power limit means the inductor with the magnetic cores have the maximum radio frequency power level above which they get the saturated, okay, and result in the non-linear response. So listen, the RF power limit, the RF power level above which they get saturated. Okay, so the level of a RF power, okay, the RF power above that it will be saturated. Okay, so when the inductor, that should be saturated region, that means the minimum saturated value should be here represented as saturated RF power limit. Okay, so next here we are I represent that some various forms of inductor. Okay, here I represented the four type. So the first one is, this is the type is the bond wire type inductor, and this is the strip section inductor. This bond wire inductor, we here consider that L is the length and width, thickness D, and in the case of strip section it will be having the length L and its thickness is T, and its width is W, and the rho is the material that's be the, it will be depend upon the material that's be used to make this inductor. And the another type are the circular type and the rectangular type. The circular type is in the form of circle, half circle, full circle. Okay, then rectangular loop is in the form of rectangle. Okay, in the form of these two, as compared with these two are loops. Okay, it will be a completed section. Okay, so these are the various forms of our inductor. The next is designing of our inductor. Okay, whenever we are going to design the inductor, we are always using the EM simulator. Okay, so the EM simulator that are used for designing our inductors. So these inductors are in MICs are fabricated using the standard integrated circuit processing. Whenever we are going to fabricate an inductor, we are always choose a standard integrated circuit processing technique. Okay, and moreover, the innermost turn of the inductor is connected to other circuiting using a wire bond connection in the conventional MICs or through the conductor that is possessed under the air bridges in the multi-level MICs and MMICs technologies. Okay, listen, for in the case of multi-level MIC and MMIC technologies, we were always using a circuitry using a wire bond connection in conventional MICs or through a conductor. Okay, so and these conductors should possess under an air bridges in between the multi-level. Okay, so and the next one is whenever the width and the thickness of our conductor. Okay, here we are using a conductor. Okay, for in the case of multi-level MIC and MMIC, we are using an extra conductors here for the connection. Okay, or wire bond connection. So that the thickness of that thickness and width of that conductor, that will be always determine the current carrying capacity of our inductor. So when if you want a inductor, this will be having the high current carrying capacity, you should be use a conductor that will be used as a wire bond between the layers in multi-layer MIC and MMIC, whose width and thickness should be large. Okay, hence you get the high current carrying capacity inductor. So this is the simple discussion about a lumped element inductor. So if you have any doubt, please comment on the box. Okay, thank you.